Going live.
Please, can you wait? Let me look at it well before people start joining.
Okay, once you are here, kindly indicate that you're okay. I can see Rubik's. Good evening. Thank you. Oh, Annabelle is here. Good evening. Who else do we have here? Yeah, if you're here, you can just indicate. You can say hi or good evening. Thank you, Marian. That's you. Good evening, Annabelle. Nice to see you guys. And Yoma, good evening. Thank you. Okay. Um, yes, I can see. You are even six now. Um, I'm supposed to start, but I hope the rest will join us immediately. Yeah, good evening, Tome Blueprint. Okay, yeah. Okay. Should I start now? Yeah, good evening, Oji. You should hear me. You should hear me. Oji, can you hear me now? Okay, let me just give the rest like 2 minutes. This is 7:04. So 1 minute or 2 minutes will start. Onigyobi, welcome. The problem with starting now is that some people will want to take us back. And I don't want anybody that will take us back behind. Okay, but before we start, there was a topic I was on before this indices, which is called number base. So I'm still going to finalize that topic, especially as regards multiplication. We had one more thing to go, multiplication of number base. And I know many of you missed that. So those of you that missed that, you would have to join um, the makeup class for that. Okay, that's just the topic you missed. So the second topic in your syllabus is indices. Okay, so now while we are waiting for others, can anybody quickly tell us what is indices in your own understanding? Yeah, you can type it. I'm waiting. So what is indices? Anybody? What do you understand in your own term, in your own language? What is indices? Anybody? I'm waiting. Hmm. Wow. Rubik says indices is the number of times a number is multiplied by itself. Wow. Amazing. Miriam says it means powers. Amazing, amazing, amazing. Any other person? Yeah, any other person? Numbers in powers of 10. Okay, no, 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 no. No, not numbers in powers of 10. Numbers in powers of 10 is called standard form. And I guess we may look at standard form immediately after indices. So not numbers in powers of 10. Okay, so I think we should go straight into it. When the others join us, they can meet us wherever we are. Um, so like I said, we are looking at indices, and this is going to be a comprehensive guide to laws simplifications, and problem-solving strategies in exponents. Okay, so I have a slide here, but of course, I'm going to be teaching you is math. So we have to be solving. I want to believe that everyone have your writing material. I believe you can see my screen. Angel, you are just coming, you see? That's the problem. Okay, so now I move to my slide. What is indices? So from my side, you can see that indices is actually a plural, and it is a mathematical shorthand. I'm sure some of you know what shorthand is. Oh, it's raining your side. Well, it's not raining my side. You can look for earpiece or something. Somebody can't see my screen. Is there any other person that cannot see my screen? Okay, let me refresh. Okay, check now. Can you see my screen? Okay, Rubik's can see it now. Okay, very good. So now indices is a plural form of index, and it is a mathematical shorthand for writing repeated multiplication of the same number. Okay, so it is a shorthand of writing repeated multiplication of the same number. And you can see an example here. And this is how we write indices. Look at this big number here. This is 2 raised to the power of 3. We call it 2 raised to the power of 3. This 2 here is called the base. That's the number you keep multiplying. And this exponent is called, this 3 is called the exponent. So if I say, let's say 2, okay. Give me a second. Let me take in my pen. So if I say 2 times 2 times 2 times 2, 2 is multiplying itself 4 times. This is 1, 2, 3, 4. That means it's going to be 2 raised to the power of 4. So that's the shorthand of saying 2 multiplies itself 4 times. If I say 5 times 5, 5 is multiplying itself only 2 times. So I'm going to say 5 raised to the power of 2. That's the shorthand way of saying 5 is multiplying itself 2 times. Now, I want somebody to do this for me. 7 times 7 times 7 times 7 times 7 times 7. Okay, so based on my explanation, can somebody quickly do that and write it on the screen? Yeah, 7 times 7 times 7 times 7 times 7 times. Okay. Are you sure you saw well? You better count well. Some of you, okay, yeah. Gina Okereke is getting that. Annabelle, good. I wonder how you guys are writing your powers with phone. I don't know how to do that. This Gen Z, you guys. I heard that heaven is very far. Yeah, Gina, you got it. Annabelle got it. So you notice that 7 multiplies itself 6 times. Oh, if you long press the number. Oh, okay. That's interesting. That's interesting. Thank you. Thank you. You taught me this one. So somebody says 7 raised to power 6. Okay, very good. So that means 7 times 7 times 7. This is, you count 1, 2, 3, 4, 5, 6. So that means I'm going to write this as 7 to the power of 6. Okay, so that's very good. Now I'm going to add one more before we continue. Can somebody tell me what 10 times 10 times 10? How do I write this? 10 times 10 times 10. Okay, so write your answers. I'm waiting. 10 times 10 times 10. Okay, Brian, that's a good one. Jack Harry, that's a good one. Okay, Annabelle, good. Gina, good. Marianne, good. Okay, so now I would have to continue. Rubik's, good. Now, that leads us to the next one. Now, these indices have some laws. There are different laws of indices, and that is why we are here. And I want us to give me your attention because I want everybody to go home very happy today. And I want everybody to go home understanding everything that we taught today. Okay, so now what we are going to look at is the first rule. The first rule is multiplication and division laws. Now, in the multiplication law, when you multiply two indices, you maintain the base and just add the powers. It's the same thing. Just add the powers. So if I have, let's say, a raised to the power of 7 times a raised to the power of 3, because I am multiplying two indices, I will just keep one of the base, just one. Then I will add their powers. It will be 7 plus 3. And that is going to be a raised to the power of 10. Okay, I want to first of all be sure. If you understand that, you say, yes, I understand. Makes sense. Makes sense. A raised to the power of 7 times a raised to the power of 3 is a raised to the power of 7 plus 3. So you add the powers. So if you understand it, please indicate, say, yes, I understand. I understand that. Okay, very good. And please be understanding because we are very soon going to get to the complex parts. Okay? Yeah, good. Now, so that means if I have, just like I have here, 2 raised to the power of 3 times 2 raised to the power of 7 is going to be equal to, once you are multiplying two indices, I will keep one base, then I will add the powers, 3 plus 7, and so that will be 2 raised to the power of 10. So which I want to believe that we all understand. Okay, I'm glad we do. Now, that leads us to the next one, which is the division law. Now, in the division law, or what you call the quotient law, to divide powers with the same base, you subtract the indices. To divide powers with the same base, you subtract the indices. So as we continue, you may see something like this: 7 raised to power 20 all over 7 raised to power 11. As long as they have the same base, keep one of the base, then subtract their indices. That means it's going to be 20 minus 11. Keep one base, which is 7, then subtract their power. So 20 minus 11, and that is going to be 7 raised to the power of 9, because 20 minus 11 is 7 raised to the power of 9. And that's the same thing here. X raised to power 10 divided by x raised to power 4 means x raised to power 6. And that's because I kept one base, I kept the base, then I did 10 minus 4, which is now x raised to the power of 6. Okay, now for me to be sure that you guys understand, I want you to do this for me quickly. 3 raised to the power of 10 times 3 raised to the power of 2 divided by 3 raised to the power of 6. Who can tell me what the answer is quickly? 3 raised to the power of 10 times 3 raised to the power of 2 divided by 3 raised to the power of 6. What would the answer be? Is binary similar to indices since it has the same base? No. Yeah, if the base is different, I will show you what to do. We have laws. There are about 8 laws, 8 to 10 laws. Okay, somebody says 3 raised to the power of 6. 3 raised to the power of 6. Okay, Jack is saying 3 raised to the power of 2. I'm afraid that, okay. Rubik's 3 raised to the power of 6. Okay, I think we are all making sense. 3 raised to the power of 6, Jack. Okay, that's beautiful. While others are bringing on their answers, now I want you to notice that the person that said 3 raised to the power of 14, that's not correct. That's not correct. So what I want you to notice before you do anything, make sure that they all have the same base. So this is 3, 3, 3, and there is division, there is multiplication, and there is division. So I will maintain just one base, which is 3. Then for multiplication, I will add their powers. Then for division, I will subtract the power. So this is going to be 3 raised to the power of 10 plus 2 is 12, and 12 minus 6 is 6. So the answer is 3 raised to the power of 6. Yes, so if you wrote 3 raised to the power of 6, then you are correct. Then you are correct. So I like to be sure that we all understand that. Angel, how did you get 3 raised to the power of 2? That's not possible. Did you divide? You see, that's the problem. You divided. You did 12 divided by 6. No, you subtract. You subtract. You subtract. So once you are multiplying two indices, you must add the powers. And once you are dividing, you must subtract the powers. Okay. Now, let me give one more before I move to the other rule. The other ones are, as we keep going, it keeps getting tougher. So I like us to give me your full attention. Okay. Now let me give one more. What if you have x raised to the power of 5 times x raised to the power of 7 divided by x times x raised to the power. Okay, you can't see my screen. Let me share it again. Let me refresh. Okay, can you see my screen now? Okay, good. Go ahead and try that. Okay, Brian, that's good. Temi, that's good. Gina, no. Annabelle, no. Um, any more trial? Marianne, no. Okay. Ami, yeah, Ami, you almost did. You almost got that. But no. Okay, let me help you guys out. Now, if in order not to make mistakes, You can choose to do the numerator first, do the up part first, then do the down part separately before you now divide. For the up part, I will say x raised to power 5 plus 7. You keep 1 and you add the powers. Divided by, for the down part, this will be x raised to power 1 plus 4. Now, anytime you see an indices without a power, it means that there is 1. It is 1. There's an invisible 1 there. So if you see 5, 5 also means 5 raised to the power of 1. If you see y, as an indices, it is y raised to the power of 1. So whenever you see that, that's what it means. And so this will now be 5 plus 7 is 12. So this will be x raised to the power of 12 divided by, this is x raised to the power of 1 plus 4 is 5. So now that I am dividing, I will subtract the powers. Remember, if you are multiplying, you add the powers, but if you are dividing, you subtract the powers. So that means this one now, I will keep the base, then I will subtract 12 minus 5. So this will now be x raised to the power of 12 minus 5 is 7. So x raised to the power of 7 is the answer. Does it make sense? If it does, you say yes. Yeah, Marian, you can see your mistake, right? For the person asking, the subject is math and the topic is indices. Okay, I'm glad it does make sense. So remember that this is the first and second rule. And you have to be careful. Remember that the condition is that the base must be the same. If the base is the same, when you are multiplying, add the powers. But when you are dividing, you subtract the powers. Okay, good. I love that. Okay, so let's move to the next one. So we now have a rule called the power of power laws. Well, even though I would have preferred something else first, but let's do this. Power of power laws. So if you want to find the power of a power, or you can say if you want to find the indices of an indices, you have to multiply the two powers. That's the first one. Now, what I mean is, if I have, let's say, a raised to power 2, and everything now is raised to power 3. A is raised to the power of 2, and everything is raised to the power of 3. It is the same thing as saying a raised to the power of 2 times 3. Just multiply the powers. So whenever you see a case like this, just multiply the powers. And so this will now be a raised to the power of 6. This is very important for you to know. Very, very important. Okay? Yeah, very important. Let me give another example. Let's say you have 5 raised to the power of 2, and you now have this to be raised to the power of 4. Once you see that there is a power inside the bracket, there is a power outside the bracket, just multiply the powers. Once you see a power inside and a power outside, that means the power of a power, or the indices of an indices, or the exponent of an exponent. These are 3 different ways you can say the same thing. Then it means that this will now be 5 raised to the power of 2 times 4, which is equal to 5 raised to the power of 8. If I'm making sense, kindly indicate. Say, yes, I understand. You are making sense. Because I'm about to give you one now. So this one is power of a power. Okay. Yeah, I love the responses. I'm watching out to see if anybody would say, I don't understand. Okay, NIBO, do not understand. Okay. Angel understands. Okay, I like that. Somebody says I'm making sense. Thank you. So for the person that do not understand, which is okay, Dodge and 2 says I don't understand. So look at another one. Let's say I have x raised to the power of 2, and this x raised to the power of 2 is raised to the power of 10. This 2 is a power inside. This 10 is a power outside. One is inside, the other one is outside. Now, power of a power means just multiply the two powers. That means this will now be equal to x raised to the power of 2 times 10, which is now equal to x raised to the power of 2 times 10 now is 20. So the answer is x raised to the power of 20. So this is what we call power of a power. So Dojan, do you understand? Me, Enaibio, Enaibe, do you understand? So while they are responding, let me give you guys one to try. Now, I want you to try this for me while others are talking. What if I have a raised to the power of half raised to the power of 24? Who can tell me what the answer is? A raised to the power of half to the power of 24. Okay, Dojan, you just joined now. You see, that's the problem. That's why I say you should always attend. Okay, Enaibe, I'm glad you understand it. So can somebody tell me the answer? Brian, that was fast. Okay. Yeah, please always be early for class so you don't get confused, by the way. Yeah, Annabelle, beautiful. Any other person? Oh, beautiful. Folake, that's good. Marian, that's awesome. Oji Roslyn, that's awesome. Temilo Lua, that's awesome. Okay, I can see. This is interesting, right? So so that means this is a raised to the power of half times 24. And all of you know that half multiplied by 24 is 12. That means 2, we cancel 24 to be 12. So you have 12, a raised to the power of 12. So if you got a raised to the power of 12, then you got it correctly. And I'm seeing that many of you are getting the same thing, and that's beautiful. I'm proud of you. So that's power of a power. Okay. I hope you will not forget, because we are climbing. It's getting interesting. Now, the next one is called power of a product. Now, when you have two values multiplying each other, they have two values and they have common power. They are multiplying each other, but their power is common. Then it means that each of them can carry the same power. For example, you have m here, you have n here, and everything is raised to the power of 5. M is multiplying n, and they are all raised to the power of 5. It is the same thing as saying m raised to the power of 5 and n is also raised to the power of 5. That means this 5 will belong to all of them. Remember, it is power of product. They must be multiplying themselves. And let me also add that they must also be dividing themselves. You can apply the rule for division. The same way you apply the rule for multiplication, you can also apply the rule for division. That means if I have something like this, please watch. If I say x over y raised to the power of 3, x over y, remember I said it is true for multiplication, it is also true for division. So it means that 3 will distribute. It means that x is raised to the power of 3 and y is also raised to the power of 3. That's what that means. Okay, I want to be sure that you understand it before I move on. Yeah, if you do, say I do. If you don't, say I don't. So go ahead, let's see. But this happens when you have two things multiplying or dividing each other. Remember, they are multiplying or dividing each other. Yeah, go ahead to let me know if you understand it. I'm waiting for your comments. Okay. Marianne, I don't understand what you did there. Okay, okay, good. Rubik's, you're not saying anything. Okay. So permit me to come again. Let me use another screen. So if I have B times G raised to the power of 4, as long as they are multiplying each other, this is power of a product. As long as they are multiplying each other, each of them have rights to the same power. It's just like saying, for those of you whose parents has more than, let's say, up to 3 or 4 children, right? What is common to the 4 of you? The 4 of you are different, but what is common to the 4 of you is that the 4 of you have the same parents. That means the 4 of you have the same father. So it's just like, this is our father. But everybody can say, this is my father, this is my father, this is my father. Each one has the same claim to the father. So anytime you are multiplying 2 values or 3 values and they have common power, they have the same power, each of them can lay a claim to that power. That means each of them can say, it belongs to me, it belongs to me. That means I can write this now as, I can say this is what? This is b raised to the power of 4 times g raised to the power of 4. All of them can lay claim to the same power. Now look at this. Even if I have a, b, c, d raised to the power of 2, they are all multiplying each other, raised to the power of 2. I can say a raised to the power of 2, b raised to the power of 2, c raised to the power of 2, d raised to the power of 2. All of them can lay claim to the same power. Yes, it also applies to division. So let me give another example. If I say, let's say, wx all over yz, and everything is raised to the power of 5, as long as this is division and multiplication, everything can lay claim to this power. That means I can write this, everything now, I can write it as 5 w raised to the power of 5, x raised to the power of 5, over y raised to the power of 5, z raised to the power of 5. Everybody can lay claim to the same power because the power belongs to all of them. Do you understand? If you do, please let me know. If you do understand, please let me know. Just comment, yes, sir, I understand. If you don't, you can say, I don't. The multiplication, no problem. Yeah, good. Now, I want to say this. Anytime you are multiplying letters, if I say B times G, it's the same thing as BG. If I say C times D, it's the same thing as CD. If I say A times B times C, it's the same thing as ABC. You know, you can write them like that. It's still the same thing. Good, 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 good. I'm sure this is making sense, right? Temilolua, are you just coming? You don't understand this part. It looks like you are just coming. Okay, is there any other person that does not understand? Okay, very good. So now let me try again. So if I say AB raised to power 10, can somebody tell me how else to write AB raised to power 10? Can you write it? AB raised to the power of 10. AB raised to the power of 10. Write the answer. How else can you write it? Brian, your blood is hot. Very hot. And it looks like your network is fast. Okay, Annabelle, beautiful. Gina, good. Kemsho, good. Chinelo, awesome. Yeah, it's no. Folake, no. You are writing the same thing. What you wrote is exactly what I wrote. Marian, good. Haja Shazan, good. Kem, good. Ruby is good. Okay, awesome. Enabio, good. Awesome. Ami, good. Yes, I like the responses. This is the same thing as saying A raised to the power of 10, then B raised to the power of 10. For those of you that said A raised to the power of 10 times B raised to the power of 10, you're also correct. Whether you write it like this or you write it like this, you are very correct. Okay, that's beautiful. Now, but I want to write one now that is not going to be smiling. Okay, Joy. Oh, okay. I'm following. So if I see, okay, Joy, good. So I'm going to write one now that is not going to be smiling. And let me see the first person to get the answer. If you are ready, say I'm ready. Comment I'm ready. It is about to go down. Yeah, Brian is ready. Yeah, Gina is ready. Is it just two persons? Okay, Annabelle is ready. Yeah. I love the responses. Good. Okay, so let me ask the question. Yeah, I like that. Now look at this. I want you to give me the answer for this. 5 raised to the power of 2 times 2 raised to the power of 3 all over 4 raised to the power of half, everything raised to the power of 10. Please don't say I'm your problem. How else can you write this? Do not say I am your problem. Yeah, think. Remember, I just taught you 2 rules now. I mean, that expression on your face is very funny. Somebody is taking the bull by the horn. Okay, Brian, that's a good one. But it can be better. Chinelo, no. But you tried. That's good. Okay. I just want you to show me another way of writing it. 5 over 4 raised to the power of 5. Okay. 10 raised to the power. Okay. Wow. Who did that dangerous thing there? Brian, that's amazing. Brian, that's amazing. Okay, you guys tried. Yeah, but let me help you out. Now, this power belongs to all of them, and all of them have power. Remember what I told you about power of a power. If they all already have power, it means that just multiply the powers. It's as simple as that. That means this one is going to be 5 raised to the power of 2 times 10. This one will be 2 raised to the power of 3 times 10. Then this one will be 4 raised to the power of half times 10. it belongs to all of them, but power of a power, you multiply the powers. So this is now going to be 5 raised to the power of 20 times 2 raised to the power of 30 divided by 4 raised to the power of 5. And I can see that Brian got that correctly. Yes. Okay, so look at that. Yes. So when you say all raised to the power of 10, distribute the 10 for everybody. Yeah, Rubik's, that's it. So do we understand that? Okay, Brian, I like that. I like that. We are getting there. We are getting there. Okay. Okay. Yeah, Brian was amazing. Okay, so whenever they all have powers, let me show you another example. Let me show you another example. Look at this. If I have a raised to the power of 2, b raised to the power of 3, okay, let me put it this way. A raised to the power of 2, b raised to the power of 6, c raised to the power of 4, everything raised to the power of half. Because sometimes you can see a question like this. These ones already have powers, and this half, this bracket shows that this half is for everybody. I belong to everybody. But because they already have powers, it means that this half is a power of a power. And whenever you have a power of a power, just multiply the powers. That means for A, it's going to be A raised to the power of 2 times half. For B, it's going to be B raised to the power of 6 times the same half. For C, it's going to be C raised to the power of 4 times the same half. You see, this half distributes. So this will be A raised to the power of 2 times half is 1. B raised to the power of 6 times half is 3. C raised to the power of 4 times half is 2. So the answer will be A, B, C squared. That's the answer. Okay. Yeah, Brian. Oh, Brian, that was sharp. That was too fast. Okay, somebody said the other question, why does 4 raised to the power of 5? Yes, because half times 10 is 5. Half times 10 is 5. Okay? Chinelo, yes, half times 10 is 5. So when I say 1 over 2, when I say 1 over 2 times 10, 2 will divide 10 5 times. I hope you get that. You're welcome. Okay, Oji Rosalind does not understand. Okay. But remember, like I said, this is the question. Everything here is raised to the power of half. And like I said, this half is meant to multiply every power here. Anytime you see a thing like this number here should multiply all the powers. And so that means I should have 2 times half. This one should be 6 times half. This one should be 4 times half. So you have 2 times half here. You have 6 times half here. You have 4 times half. And half means like 2 we cancel 2 to be 1. 2 we divide 6 to be 3. 2 we divide 4 to be 2. I think this is simple fraction. It should be easy. It should be easy. Yes, I don't need to write 1. I told you whether there is 1 or there is no 1, it's fine. Oji, do you get it now? Okay. Okay, I want to try again. I want to try again. I want to try another one. So please watch. Okay, maybe you guys should try this for me. A Can somebody tell me another way of writing this? Somebody said I did not write cube. I did. Okay, cube. Thank you. Thank you. So somebody try this. Brian, what kind of computer are you using? Why are you that fast? Yes, I've written it. Thank you. Annabelle, I've written the cube. Thank you. Chinelo, you did not finish. I think Brian is using a very fast computer. Annabelle, Ami, amazing, amazing, beautiful. Annabelle, beautiful. Brian said math is my favorite subject. I can see. I've corrected it. I've written the B cube. Angel. Marian, yes, now that's beautiful. Yeah. So, yes, Chinelo, now you finished it. Very good. Enyabe, that's very good. Okay, so I can see that everybody got this correctly. So this is the same thing as saying a raised to the power of 1 times 2, b raised to the power of 3 times 2, c raised to the power of 5 times 2. So that will be a squared, b 6, then c 10. So everybody got this correctly. I think I'm proud of everybody here. Okay, and I think I'm proud of myself too. Yeah, amazing, 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 amazing. Okay, now I want to ask a very dangerous question. Are you with me? If you say you are ready, if you are ready, let me know. Are you ready for the next dangerous question? The first person that gets it will get airtime, 100 naira. Okay. I can see a lot of people saying they're ready. Okay, now look at this. Let me see the first person to answer that. Instead of you to solve, you are calling Brian. It looks like Brian is some people's enemies of progress. And I want to see your working. Okay. Is it only on your phone? Is there any other person I'm frozen? Am I frozen on any other end? I think that's your network. Annabelle, 1 raised to the power of 2. Hmm. Hmm. Okay. Okay, yeah, thank you. Okay. I'm waiting. Okay. Somebody says 6 raised to the power of 5. I want the smartest answer. Okay, Rubik's. 1 raised to the power of 2, Annabelle. I wonder. 1 raised to the power of 20. Hmm. Interesting. Okay. Rubik's is the first person to get the answer correctly. The answer is 1. The answer is 1. And let me show you how to get this quickly. Let me show you how to get this quickly. Now, I want you to notice something because these kind of questions, you should expect them. Everything is having the same power. This one has 5, this one has 5, this one has 5. I can simplify this by saying, I can write it as 2 times 3 divided by 6. Everything raised to the power of 5. Everything has the power of 5. Everything has the power of 5. And so look at this. 2 times 3 is 6. 6 divided 6 is 1. So you now have 1 raised to the power of 5. And 1 raised to the power of any number is still 1. So 1 is the answer. Very simple. This is where they say, ta-da! Yeah, Brian, you missed airtime. So Rubik's, you send me your number so I can send you the airtime. So the answer is 1. Okay, I like to be sure that you guys understand it. If you understand, let me know. So you see, once you see powers, similar powers, you can group them as 1. It's the same thing. What we learned. Yeah. Okay, good, 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 good. So I want to move on to the next thing. So you can see that you have plenty things to practice today. I wish I can stop here, but I have to continue. Okay, so let's move. So we are done with 4. Okay, this is number 3, number 4. So I'm about to move to the next one. So this one is saying 0 and negative law. Now, when you say 0 and negative law, the first one is 0 law. Yes, Ogun Tuase. Bukola, yes, you can try another method. Yes. You can actually raise them to the power, then divide. You will still get 1. Is acceptable. I'm just doing this to, show us that we should be smart. Okay, so the third one is 0 and negative indices. Now, the first one there says 0 law. Any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. So even if I say, let's say I have 10 raised to the power of 0, it is 1. 20 raised to the power of 0 is 1. 100 raised to the power of 0 is 1. 1000 raised to the power of 0 is also 1. Yeah. So any number raised to the power of 0 is 1. Do you get that? Yes. Then the second one is called negative index. Now, a negative index is an inverse. I can see some people are leaving the next one is negative index. Now, anytime you have negative index, it means inverse. It means 1 over. You invert it. Like a raised to the power of minus n means 1 over a raised to the power n. And this can be in many forms. If I say 5 raised to the power of minus 2, as long as the index is negative, it means 1 over 5 raised to the power of 2. If I say 10 raised to the power of minus 3, it means 1 over 10 raised to the power of 3. That means once you invert the number, the power will disappear. And amazingly, there are many ways. There are many ways this can be applied. Many ways. For example, if you have something like this, 2 over 5 raised to the power of negative 3. Because this is negative, because the index is negative, it will invert the fraction. It will reverse the fraction. That means instead of saying 2 over 5, it will now be 5 over 2, and why this will become 3. So a negative index always inverts fraction. A negative index always inverts fraction. A negative index always inverts a fraction. Are you following me? A negative index always inverts fraction. I think you guys should focus on what I'm saying. So if I have can somebody now tell me what this, another way of writing this? 1 over 2 raised to the power of minus 3, based on what I just explained. 1 over 2 raised to the power of minus 3, based on what I just explained. Okay. I like what I'm seeing. I like what I'm seeing. Dara Simi, that's a no. Okay, so you can write this as 2 over 1, then raised to the power of 3. And please write like a mathematician. There is something you will write, and the invigilator will know that you are an amateur mathematician. But if you're a strong mathematician, you're expected to know that 2 divided 1 is still 2. So I can still write it as 2 raised to the power of 3. So sometimes behave like a mathematician. Sometimes oppress them. Remember that once you invert the fraction, the negative sign will disappear. Once you invert the fraction, the negative sign will disappear. Do we understand? If you understand, comment, yes, I understand. Yeah, I like what I'm saying. I like the responses. If you understand, comment, I understand, I understand, I understand. So I'm about to write another one. Okay, very good. Okay, let me also say this. Now, the beautiful thing about math is that there is not just one way of doing the same thing. There are different ways of achieving the same results. Not just one way. There are different ways of achieving the same result. Now, I want to solve this in another way, and I hope you will be ready to see. So watch what I do now. Remember, I started with 1 over 2 raised to the power of minus 3. Yes. In maths, why I love maths is that there are different ways you can achieve the same result. So see what I'm about to do. This 1 over 2, I can write it as 2 raised to the power of minus 1. 1 over 2 also means 2 raised to the power of minus 1. Based on what I taught you, it's still the same thing, inverse. Then this is power of a power. Power of a power means I should multiply the power. That means it will be 2 raised to the power of minus 1 times minus 3. And that will be 2 raised to the power of minus 1 times minus 3 is just 3, because negative sign will cancel negative sign, and you have this. This is another way of getting the same answer. Interesting, 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 interesting. Do you understand my second method? Does it make sense? Good, good, good. I love the response. Yeah, good. So you see, there are different ways. There are different ways. There are different ways. Okay, maybe I should repeat myself again. Yeah, actually very interesting to learn. Yeah, it is. Okay, let me try. Okay, Anne says she preferred this. Annabelle, you prefer this. Okay. So let me say this. Remember that if I say 1 over 5, it's the same thing as saying 5 raised to the power of minus 1. It's the same thing. 5 raised to the power of 1 is 1 over 5. 1 over 5 is 5 raised to the power of 1. I can interchange it. 1 over 2 means 2 raised to the power of 1. That means 2 raised to the power of 1 also means 1 over 2. I can interchange it. This is inverse law or negative index law. Negative index can be a fraction. Negative index can be a fraction. If I say 1 over 3, it's the same thing as saying 3 raised to the power of minus 1. So if I say 1 over 2 raised to the power of minus 3, I can rewrite this one inside here by saying 2 raised to the power of minus 1. Because 1 over 2 means 2 raised to the power of minus 1. Then you have minus 3 out here. And so this is now going to be minus 1 times minus 3. Minus 1 times minus 3 is plus 1. Don't forget that minus times minus is always plus. Okay, so I want to believe that this is clear now. I want to believe that this is clear. I want to believe this is clear. Right? This is clear. Okay. Very good. Very good. Very good. Okay, so I want to ask a question. Yeah. What if you interchange it? I wonder what you mean by interchange. But if you mean, if interchanging it means writing this as 2 raised to the power of minus 3 raised to the power of minus 1, you are still correct. It's still the same thing. You will still arrive at the same answer. Okay. Now I want us to do something. Write these numbers as a product of each other. I want all of them to be on the same level. So can you give me the answer? Write it as a product, not as a division. That means eliminate the division. You say I wrote rivals. Okay, no, I'm not the one that wrote rivals. Joy, you're almost there. Brian, no. Enya, no, 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 no. Temi Lolua, no. Write all of them to be product of each other. Okay, Gina, you tried, but no. Okay, let me help you guys out. Now, in order to write this to be on the same level, watch. This is going to be a cube, b4. Then this one will be c minus 3. And this one will be d minus 2. They are now on the same level. Do you see that? So that means if you want to bring denominators up, just put their powers to be negative. That's what that means. It's still the same thing, negative index. I don't think I saw anybody that got it. So that means if I have x over y, let's say x squared over y cubed. Another way I can write this is x squared, then y raised to the power of minus 3. This is another way I can write it. These are the different things you should know in maths. How is it minus 3? Remember, c is a denominator. C raised to the power 3 is a denominator. If it comes up, that means if you want to make it a numerator, it has to have a negative value. It's still the negative index. So fraction is the same thing as a negative index. Fraction is the same thing as a negative index. Let me give another one. Look at this. This one now, I can write it as, do you see that? Once the denominator wants to come up, it will carry a negative sign because a fraction is a, now let me remember that if I say m over n is the same thing as saying m times 1 over n. It's the same thing. M times 1 over n. That means it's going to be m times 1 over n means n raised to the power of minus 1, which means mn to the power of minus 1. You guys need to know this, so you must know this today. I'm not going to move on today until we have known this, because the purpose of this class is for us to understand, right? Can you people stop gisting and face what I'm showing you? Okay, so now look at this example, or look at this question. I want you guys to do this for me. Okay, so write the following in fraction form. Okay, so I need your answers. Who is going to be the first person? And by the way, while you are solving, if you have not liked the video, please go ahead and like it. Okay, the first one is correct. Gina, correct. Darasimi, no. Annabelle, no. Number 2, Darasimi, no. Please calm down. Go back to what I taught you. Go back to what I taught you. Make sure you are doing the correct thing. Brian, I have a problem with your number 4. Chem show math, that's good. Gina, I like your answer. Joy, yes. Annabelle, yes. Bukola, yes. Rubik's, yes. Yeah, Rubik's, your okay, Rubik's, yes, good. Chem show math, no, that one is not correct. Okay, I like our answers. Rubik's, beautiful number 2. Joy, beautiful. Eniabe, beautiful, but you forgot to put 5. Okay, let's do them together. We are going to stay on this mountain. We are going to stay on this mountain. Okay, so compare it with what you did. Number 1, x raised to power minus 2 is equal to 1 over x raised to power 2. If you understand that, if you got that correctly, you can say yay, 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 yay. If you got number 1 correctly, and if you understand it, you can give me a thumbs up, or you shout yes, yes. Yeah, yes. So I guess that's the easiest. Okay, good. Now, okay, oh, good, amazing. Now, for the number 2, 2a raised to power minus 1. This minus 1 is just for a, so that means a will become a fraction. That means it's going to be 2 over a. If you understand that, yeah, I like that shout. If you understand number 2, scream yes. Oh, clock it. Yeah, good. If you understand it too, you can, this is getting interesting. I like that, Dojan. Clock it. Yeah, good. Okay, I'm about to do number 3. Now, number 3, to convert this to a fraction. Now, if you notice, this negative sign is for everything. So that means it's going to be 1 over 3d raised to the power of 2, like this. Or you say 1 over 9d squared. If you got it, yeah, I like that. I like that. I like the responses. Beautiful. Yay, beautiful. Beautiful. Okay, then number four. Okay, then number four. Now, number four wants to look tricky, but this thing means 1 over 2 times 1 over w squared. That means I can write it as 1 over 2w squared. If you are clocking it, you better clock it down. So w raised to power 2 is 1 over w squared. I like that. I like that. Nice one, Marianne. Nice one, Oji. Nice one. Yeah. Amazing, 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 amazing. By the time you guys resume school, then the 5-1, the last one, Dodge and say I'm shocked. Yes, 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 yes. Okay, so then this one, number 5, finally, k raised to the power of -5 is the same thing as saying 1 over k raised to the power of 5. This one is the easiest of them all. Yeah. Oh, you can't see my screen? Let me refresh. Okay, can you see my screen now? Chinelo, no, I've already solved number 4. Can you see my screen now? Okay, good. Oh, very good, very good, very good. No, not k over 5. Chinelo, you are twisting it. It's 1 over k raised to power 5. Yes, I've been seeing yours. Your number 4 and number 5 is not correct, Chinelo. Okay. So I want to give you guys some more. Look at my number 4 and 5. Chinelo, yours is not correct. Okay. So are you ready for another round? Are you ready for another round? If you are ready, say, I am ready. Yeah. Yeah, 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 yeah. Okay. So I'm about to write the next set of questions. So listen to this. Okay, so I'm waiting. You guys, when I don't start. Okay, Annabelle, that's a good one. Annabelle, your second one is correct. The third one, amazing. People are complaining. Why are you rushing? No, Gina, no, that's wrong. Gina, there should be no. If you are converting negative index to fraction, there will be no negative sign anymore. Darasimi, good. Okay, Bukola, good. Enyabe, beautiful, beautiful. Oh, amazing. But you made mistake in number 2, Enyabe. Which one is equal to again? Okay, number 2. No, Bukola, that your number 2 is not correct. Then Angel Fortune, number 1 correct, number 2 correct, number 3 no, number 4 no, number 5 correct. Angel Fortune, you made mistake in number 3 and 4. Then Dodger, number 2 correct. Annabelle, no, that B minus 1 is not it. Dodger, no. Keep your answers coming. Okay. Let me do it now. Then you guys compare it with what you've done. Chinelo, you are good with math in Jesus' name. That's why you are here. That's why you are here. So don't be scared, right? Just follow your instinct. Okay, so watch what I will do. This is the only one that has a negative power. So it's going to be a fraction. That means this one now should be AB squared. So compare my number 1 with what you did. So the one that has the negative index is the one that will be changed to a fraction. You can't see my screen. Fumilola, try to watch the video after now. So let me explain again. Now, this one that has a negative power is the one that will become a fraction. Negative index means fraction. Negative index means denominator. Negative index means denominator. So that means this one now will become a denominator, C cube. So once the negative index disappears, your C cube becomes a denominator. If you understand it, please let me know that you understand it. I like that. I like that. For those of you that didn't get it, do you understand it? Okay, Annabelle, good. Folake, very good. You did a very good job. It's Folake, you did a very good job. Okay, let me do number 2. Please, let's follow. So number 2, W raised to power minus 3 means that W3 will be a fraction. Do you get this one? Good. Good, 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 good. 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 Okay. Then the other one, 25y raised to power minus 1. This one now, this negative index, y to the power minus 1, means that y is a, that means I'll write it as, or, so who got number 3 and who understands number 3? No, you can't say w over 3. No. Both w and 3 will be a denominator. Bukola, both w and 3 will be a denominator. That negative power will become a fraction. Okay, very good, very good, very good. Enai Bio, that's good. Enai Bay, that's very good. Okay, let's try another one. Number 4. These two will come under. And let me also say this. This also means 1 over 27. Remember, 3 raised to the power of 3. 3 raised to the power of 3 means 3 times 3 times 3. 3 raised to the power of 3 means 3 times 3 times 3, which is 27. Yeah, Gino, you're correct. So are you guys seeing this? Are you getting this? If you want to expand, you can expand it. It's fine. Okay, so let me do number 5. This thing is for everybody, which means if you did, you are still correct. Check your number 5. Does it work? Is it clocking? Yeah, Marian, yes. I like that. I like that. I like that. I need responses. Good. Good, 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 good. So, number 6. These two that have negative index will come under. Then this other two will stay on top. Clock it. Clock it. Clock it. Oji does not understand. Which number? Oji. Roslyn, what number? Yeah. No, I added raised to power. Added it. Beautiful. Okay, so yeah, Oji, I get you. I will come again. Okay, Oji, even though I know you came late, I want to explain using this. 7a, b minus 2 fraction, x minus 3 fraction. So that means because of these negative powers, I'll have this. 7a will be on top. Then this one will be under. B squared will be under. X3 will be under. This negative power is the reason for this. Oji, do you get it? Oji, do you get this? If you don't, still say you don't. As long as I see negative powers, then those ones that have negative powers will come under. Then the ones that don't have negative power, A and C, will stay on top. Oji, do you get it? Please, I like attention. Don't worry about others. Okay, good. So now I want to write another one. Can somebody write this as a fraction quickly? Can you write this as a fraction? 3ya minus 3. Write it as a fraction. No, it is A and C that is not affected. And the reason why A and C is not affected because they don't carry any negative power. Enyabe and Gina, can you try that again? Bukola, nice one. Kem, can you focus and stop writing? Fumilola, beautiful one. Rubik's, no. Okay, Gina, you tried, but you're making a mistake. Okay. Now, please, I want everybody to calm down. I want to explain something very clearly. I want to explain something. Yeah, Enyabel, good. Angel Fortune, good. But please, I want to explain something. Listen. Now, this is not the same thing as this. They are not the same thing. This and this are not the same thing. This one means that this minus 3 is for only A. But this one means that minus 3 is for everything here. So this one now can be equal to, I put my this, A cube will come under, 3y will stay on top. But this one means all of them. I hope you can see the difference. I hope you can see the difference. I hope you can see the difference. Okay, because of time, I'm going to stop here. Because of time, I am going to stop here. Practice makes perfect. Practice makes perfect. Practice makes perfect. So what are you guys going to do after now? I may give you guys 50 questions to go and practice with. So I'm going to post 50 questions for you to practice with. Practice, practice, practice. Brian, let's see. Enyabe, good. Okay. Yeah, 50. Expect 50 questions. Practice, 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 practice. No, 50. I want to give you sleepless nights. Moreover, if you have not liked the video, you can go ahead and like it. I'm going to stop here. So let's go and practice. Have a nice day. Bye-bye. Bye. Bye. Continue your chats. Continue your chat on WhatsApp.